General studies video lectures, notes and practice question sets for ESE, and other exams. In this video we had discussed a subtopic of energy and environment, which is water conservation. First we have to know that what is water treatment. Let's start with methods of water treatment. Water is treated by a variety of physical and chemical methods. Treatment of surface. Water begins with intake screens to prevent fish and debris from entering the treatment. Plant and damaging pumps and other components. Conventional treatment of water primarily involves clarification and disinfections. Clarification removes most of the turbidity, making water crystal clear. Disinfection, usually the final step in the treatment. And drinking water destroys pathogenic microbes. In addition to clarification and disinfection, the processes of softening, aeration, carbon adsorption, and defluoridation may be used for certain public water sources. Desalination processes, that is, removal of excess salt from water, are used in areas where fresh water supplies are not readily available or the groundwater is saline. A clarification or sedimentation. Impurities in water are either dissolved or suspended. The suspended material reduces clarity, and the easiest way to remove it is to let suspended particles settle. Coagulation and flocculation. Suspended particles cannot be removed completely by plain settling. Large, heavy particles settle out readily, but smaller and lighter particles do not settle easily. Such particles are called colloidal particles. To remove such smaller particles, alum is added. Alum causes flocculation. Flocculation is a process through which all the finer insoluble particles form large particles called flocks. These flocks then can easily settle and thus are removed from water. Aluminium sulfate. Alum is the most common coagulant used for water purification. Other chemicals, such as ferric sulfate or sodium aluminate, may also be used. The flocculation tank has wooden paddle-type mixers that slowly rotate on a horizontal motor-driven shaft. After flocculation, the flocks are allowed to settle in a settling tank. From here the supernatant is passed through sand filters. Microstrainers are used mainly to remove algae from surface water supplies before conventional gravity flow filtration. Even after coagulation and flocculation, sedimentation does not remove enough suspended impurities from water to make it crystal clear. Filtration is a physical process that removes these impurities from water by percolating it downward through a layer or bed of porous, granular material such as sand. Suspended particles become trapped within the pore spaces of the filter media, which also remove harmful protozoa and natural color. Most surface water supplies require filtration after the coagulation and sedimentation steps. When clogged by particles removed from water, the filter bed must be cleaned by backwashing. In the backwash process, the direction of flow through the filter is reversed. clean water is forced upward through the media, expanding the filter bed slightly and carrying away the impurities in wash troughs. The backwash water is distributed uniformly across the filter bottom by an underdrain system of perforated pipes or porous tile blocks. Because of its reliability, the rapid filter is the most common type of filter used to treat public water supplies. However, other types of filters may be used, including pressure filters, Paytm ESE filters, and microstrainers. As pressure filter has a granular media bed, but, instead of being open at the top like gravity flow rapid filter, it is enclosed in a cylindrical steel tank. Water is pumped through the filter under pressure. In Paytm ESE filters a natural powder-like material composed of the shells of microscopic organisms called diatoms is used as a filter media. The powder is supported in a thin layer on a metal screen or fabric, and water is pumped through the layer. Pressure filters and Paytm ESE filters are used most often for industrial applications or for public swimming pools. Microstrainers consist of a finely stainless steel wire cloth mounted on a revolving drum that is partially submerged in the water. Water enters through an open end of the drum and flows out through the screen, leaving suspended solids behind. Captured solids are washed into a hopper when they are carried up out of the water by the rotating drum. Microstrainers are used mainly to remove algae from surface water supplies before conventional gravity flow filtration. B. Disinfection. Disinfection destroys pathogenic bacteria and is essential to prevent the spread of waterborne disease. Typically the final process in drinking water treatment, it is accomplished by applying either chlorine, ozone or ultraviolet radiation to clarified water. Chlorination. The addition of chlorine or chlorine compounds to drinking water is called chlorination. Chlorine compounds may be applied in liquid and solid forms, for instance, liquid sodium hypochlorite or calcium in tablet or granular form. However, the direct application of gaseous chlorine from pressurized steel containers is usually the most economical methods for disinfecting large volumes of water. Taste or odor. Problems are avoided with proper dosages of chlorine at the treatment plant, and a residual concentration can be maintained throughout the distribution system to ensure a safe level at the points of use. Chlorine can combine with certain naturally occurring organic compounds in water to produce chloroform and other potentially harmful byproducts. The risk of this is very small, however, when chlorine is applied after coagulation, sedimentation, and filtration. Ozone. Ozone gas may also be used for disinfection of drinking water. However, since ozone is unstable, it cannot be stored and must be produced on site, making the process more expensive than chlorination. Ozone has the advantage of not causing taste or odor problems. It also leaves no residue in the disinfected water. The lack of an ozone residue, however, makes it difficult to monitor its continued effectiveness as water flows through the distribution system. 9.4.3 Other methods of water purification. Sometimes natural contaminants like fluorides, iron or arsenic are present in water. These impurities are harmful to human health. There are methods to remove these impurities. Removal of fluoride. Fluoride is generally present in all natural water. Its concentration up to certain level is not harmful. Beyond that level, the bones start disintegrating. This disease is called fluorosis. We have fluoride problem in many parts of our country. Bureau of Indian standards prescribes 1.0 ml as desirable and 1.5 ml as maximum permissible limit for drinking water. Any water containing high level of fluoride needs to be treated for removal of fluoride in order to make it safe. The simple treatment technique which can be adopted at household level is described below. Domestic defluoridation. Defluoridation at domestic level can be carried out in a container bucket of about 60-liter capacity. The bucket should have a tap 3-4 centimeters above the bottom for withdrawal of treated water after treatment. The water for treatment is taken in the container, is mixed with inadequate amount of aluminum sulfate alum solution, lime or sodium carbonate and bleaching powder depending upon its alkalinity concentration of bicarbonates and carbonates in water and fluoride contents. Alum solution is added first and mixed well. Lime or sodium carbonate solution is then added and water is stirred for 20 minutes. Then it is allowed to settle for nearly 1 hour and then withdrawn through tap for consumption. The settled sludge is discarded. Normally 100 to 600 milliliters of alum solution is required to be added in 40 liters of water containing fluoride ranging from 2 to 9 mol. In order to remove it to acceptable level. Defluoridation at community level. The community-used technique for community water supply is called Nalganda. Technique developed by National Environmental Engineering Research Institute, NERI, Nagpur. It has following components: reactors, sump well, sludge drying bed. This is a batch method for community up to 200 population. The tank is equipped with mechanical agitator operated manually or by electric motor. Water is pumped or poured into the tank in a required amount of alum, lime or sodium bicarbonate, and bleaching powder is added with constant stirring. The contents are stirred slowly for 10 minutes and allowed to settle for 2 hours. The defluoridated supernatant water is withdrawn and supplied. The sludge from the bottom is discarded. Removal of iron. In many parts of our country we have problem of excess iron in drinking water, especially in northeast regions. Iron causes bad taste and odor to the drinking water. Bureau of Indian Standards prescribes desirable limit for iron as 0.3 mol. Removal of iron is essential. At domestic level, this is the simplest unit developed by NERI. It involves aeration of raw water over a series of coke, marble/calcite bed followed by slow sand filtration. No chemicals required for treatment. Up to 200 L/hour of water can be treated at community level. The treatment is a sequential process of aeration, reaction, setting and filtration. The main part of the treatment plant is a vertical cylindrical vessel having following chambers. 1. Aeration oxidation chamber. 2. Settling filtration chamber. 3. Final collection chamber for treated water. Water from the hand pump is sprinkled from the top. This will ensure contact with air for complete aeration. A major part of iron is oxidized here. Then the water is made to react with oxidizing media limestone. The remaining iron is oxidized in this chamber. By aeration and further oxidation, the dissolved iron is converted to insoluble ferric hydroxide. The insoluble iron can thus be easily removed through filtration. Then it is passed through filter media, sand and gravel filter. The filtrate water contains iron in an acceptable range. Removal of arsenic. Arsenic is found in groundwater in some parts of West Bengal. Arsenic is highly toxic in nature. It may cause a number of skin disorders or even cancer. Bureau of Indian Standards prescribes desirable limit for arsenic as 0.05 mol. Removal of arsenic is essential. The treatment technology developed by Institute of Public Health and Hygiene, cocator, is commonly used. The technology is based on oxidation, coagulation, flocculation, sedimentation and filtration. Bleaching powder and alum are used for removal of arsenic. It consists of 3 chambers. In the first chamber the chemicals are added. The mixture is then passed to next chamber called settling tank, where it is allowed to settle for 2 hours. The supernatant is then passed through a slow sand filter. The filtrate water generally contains arsenic in the acceptable range.